Let's take a look with dealing with a projectile that is launched at an angle. So imagine we have a kicker who is going to kick a ball from ground level, and he kicks this thing with an initial velocity of 20 meters per second at an angle of 35 degrees. I want to know how far the ball goes. Well, just like before, we have to deal with this in two dimensions simultaneously but separately from each other. So I have my x positions and my y position equation and information. So I want to know how far it goes, right? I want to know delta x. I don't know what that is. I've given some information, but not initial velocity in x. Remember, this thing is kicked at an angle. That means some of that velocity is to the right in the x direction, but some of that velocity is vertical in the y direction. And just like dealing with forces, we can deal with velocities. So if I want to know the initial velocity in x, that's the side adjacent to my angle, so I'm going to use the cosine. Cosine of 35, well, I guess if I was using red for x, I'll use red for x. So cosine of 35 degrees is equal to my adjacent side x, which is, this is the velocity in x, and this is the initial velocity in x, v naught x, over the hypotenuse, which in this case is 20 meters per second, not 20 meters per second squared. So 20 meters per second, which means my initial velocity in x is 20 cosine 35. So if I actually do the math on that, I know how fast it's going in the x direction. 20 cosine 35 is 16.4 meters per second. And so I can go ahead and record that over here. My initial velocity in x is 16.4 meters per second. And the acceleration in x, well, there won't be any forces acting in the x direction, right? When the ball's up in the air, then we'll have gravity acting down, but there's no acceleration left or right, so my acceleration in x is 0, just like before. And so I have the equation, change in position, delta x, equals 1/2 at squared plus v naught t, but acceleration is 0. So really the change in position in x, how far it goes, its range, is v naught t. Well, I know v naught, it's 16.4, but I don't know t, so I can't find this yet. Which means, of course, let's head over to the y direction. In the y direction, I know where it starts. Its initial position is on the ground. I also know where it ends because I want to know how far it goes. Well, it stops when it hits the ground again, so its final position is also 0. I know the acceleration in the y direction. Acceleration y is negative 9.8 meters per second, the acceleration due to gravity, and its initial velocity in y I don't know, but I can find. It's this side of the triangle. So this is the opposite side, so the sine of 35 is equal to the opposite side, velocity in y, over the hypotenuse, 20 meters per second. So 20 sine 35 gets me my velocity in the y direction, which is 11.47 meters per second. So v naught y equals 11.47 meters per second. I'm going to go ahead and put that in over here. Now I can figure out how long this thing has been in the air. Remember, I have the same equation, delta y equals 1/2 at squared plus v naught t plus, well, this is delta y, so I don't have anything else over there. But remember, delta y is just final minus initial, y minus y naught. So really, it's changing the vertical position, even though it goes up and comes back down, since it starts and ends at the same spot. 0 is just 0. So I have 0 equals negative half of 9.8 is 4.9 t squared plus 11.47 t. Now, here's where we have to be careful. There is a t in both of these terms because it started and ended at the same point. So I can divide a t out of every term. I can divide by t here, I can divide by t here, and I can divide by t here. 0 divided by anything is still 0, equals negative 4.9t plus 11.47. Now I can subtract over my 11.47, and I can see 11.47 divided by 4.9, whoops, forgot my t up there, divided by 4.9 gets me my time. 11.47 divided by 4.9 is about 2.34 seconds. So t equals 2.34 seconds. Now I can use that up here in my x direction because it'll go until it hits the ground. So my initial velocity in x, 16.4, times that 2.4 or 2.34 seconds gets me a range of 38.4 meters. So this ball goes 38.4 meters when it's kicked at 28 meters or 20 meters per second at an angle of 35 degrees.